So now this is going to be our third example dealing with equivalent fractions, and this is going to be a different kind of problem. The question now is, can I write a fraction equivalent to 3 but with denominator 4? First of all, you're saying we were talking about equivalent fractions, but 3 is not a fraction, right? And so we're going to immediately use our rule to rewrite 3 as 3 equals to 3 over 1, right? That's number one. I have now written it as a fraction. But now I wanted to have a denominator of 1. So I ask myself, okay, if I want an equivalent fraction, I can see from my rule here that I can get an equivalent fraction from another by multiplying the fraction that I have by a fraction that equals 1, right? So I can get an equivalent fraction from the other by multiplying the fraction by a fraction that equals 1. So here I have 3 over 1, and I'm going to multiply it by a fraction that equals 1. Now we remember from our other rule that for a fraction equal 1, it must have the same numerator and denominator. So I ask myself, and when I multiply fractions, I multiply the numerators to get the new numerator, and I multiply the denominators to get the new denominator. So I ask myself, okay, I want a denominator of 4. 1 times 4 would equal 4. Therefore, if I multiply the top and bottom here by 4, I will get the fraction 12 divided by 4. Because 3 times 4 is 12, and 1 times 4 is 4. And so therefore, 3 became the fraction 3 over 1, which when I multiplied it by the fraction 4 over 4, which equals 1, I got the equivalent fraction 12 over 4. And of course, you might already know this, 12 divided by 4 is 3. So in fact, 12 over 4 is exactly 3. But now, 12 over 4 is written as a fraction with denominator 4. And this is going to be very important soon as we learn to add fractions and subtract fractions with different denominators. Thank you.